Okay, hey, hopefully I am audible now. Can you hear me, Nathan?
I can hear you, sir.
Cool, so we must be working. I haven't used StreamYard in a while, so we'll see how this actually goes. But I'm trying something different this week. We might be joined by some other folks here in a bit, but I'm going to do my normal Anachro weekly update kind of thing and talk about how it's going. And this time we'll have Nathan here. Looks like Kevin is also joining us. Hey, Kevin, how's it going? We can't hear you, but I'll check back in a second. But I'm going to do my normal Anachro update. But this time I felt like having a comment gallery of people who can ask me silly questions about why I'm doing certain things and how terrible it is. And then probably after I do my update, because I don't have that much to share, I figure we'll just chat about stuff until we get tired of chatting about stuff. So do you have audio now, Kevin?
Can you hear me?
You tell me.
Oh,
Yes.
I can hear you. Yeah.
Cool.
Hi,
So,
Kevin.
Kevin, you want to
Okay,
introduce
great.
yourself real quick?
Yeah, my name is Kevin Leina. I'm a longtime technologist, and I've been kind of goofing around with Rust in the embedded space, for maybe the past year and a half. My background's actually doing a lot of stuff in the web with Clojure, and I picked up Rust because I wanted to write small things that were very fast, and I knew that I wasn't able to do that with the JVM underneath me or with JavaScript engine. So that's how I got into Rust world, and yeah, I don't know, been having a good time.
Cool. And then
You'll be happy to know that there's a constant struggle internally at Oxen. I'm Nathan. I'm the CEO at Oxen. To turn our verification language into some kind of Lispy-like thing. And I've become increasingly amenable to it, which is only putting things further at risk.
You want to give
Nice.
yourself a quick intro, Nathan, then?
Oh, yeah. So I'm Nathan Ashbacher. I'm the CEO of Oxen Corporation. We build sort of test and verification tooling for robots and embedded systems of systems.
Very cool. So, quick reminder of what this is. So this is Anachro PowerBus, which is sort of like the second generation of me attempting to build a smart home platform entirely from scratch. Because I worked in IoT for a couple years, and I told myself, if I'm going to put IoT devices in my house, I better build them from the ground up, because I don't necessarily trust any of the ones that are out there. And, good reason to do it, I guess. But yeah, I've been working on this revision of hardware. I should probably have something easier to grab than my giant test rack, or I should have come prepared and pulled pictures. Nah, this is gonna be terrible. I have pictures of this. Let me pull up some pictures, because I'm gonna drop all my hardware everywhere, and that's gonna be terrible. Let me go pull up some pictures. So over the last, I think in the last update, I had just built 4 more power supplies, because I built the first unit, fried it, because I'm pretty sure I made the regulator very sad and it decided to put 20 volts out instead of 5, and most devices do not like that. So I was reassembling some new boards, and I think last time I had the power supplies reassembled, but I hadn't had the whole boards. So since our last let me hide DMs. But since the last update, I've gotten 4 of these built up and installed. So now I have them on my nice little Lego test rack here, where I've got a USB hub for the debuggers. I've got my 3 devices that are all powered up, and they each have their own debugger. I've got power coming in over here that's injecting power for the whole bus. And everything's nice and daisy chained. So this is all running RS-485. So these 2 ones, you'll notice, are connected on their B port, because that one has a terminating resistor to make sure that the line's balanced. And then this one's using the daisy chain A port. So basically, we've got one end of the bus here, goes in here, daisy chains, and then the other end of the bus here. And since building this, I was able to write enough software where they can actually talk to each other. So I did some basic serial tests where they can talk, and I'd show you videos or pictures of them working with the lights on, but LEDs are way too efficient nowadays, which means as soon as I point a camera at them, I'm in a lens flare movie. But I got them talking to each other, and let's go to this tweet. And you can see them sort of ping pong blinking, because I had this one sending, and then both of these were just listening all the time. So whenever this one sends, it toggles the LED, And whenever these ones hear it, they toggle their LED. So this was basically, I hadn't screwed up the RS-485 circuit too poorly, I guess. So they were able to talk. I'm able to flash all of these. Ran into a problem, so I'm using these black pill boards as debuggers because it turns out these are like the cheapest SWD debuggers that you can get. I think you could do this with a blue pill too, which is even cheaper, but these are one of those things that I keep in a drawer, and I have these as stocked parts basically because I throw them in everything. The only problem is the firmware image that comes with them has a hard-coded serial number in it, which means when I was trying to tell all of my tooling to connect to a specific device, they all had the same serial number, so I couldn't just select one device. So I hex edited the binary and gave them each individual serial numbers, and now I can address them as separate debuggers, and for $30 I have 3 or 4 SWD debuggers, which is less than the cost. I mean, I have a J-Link and I really like it, but it costs like $200, and I don't have $800 for my silly test lab setup here. So we get wires and an STMF4 dev board.
There's a lot of wires going on in this picture. Let me see if I can tell what's going on, and you tell me where I'm missing.
Sure, let me go to the
here,
one that's in better resolution here.
Yeah, so you have these blue pills using as debuggers, and these are all hooked up to USB via this hub at the top. So you're talking with that over your laptop or whatever, right? And that's how you're flashing these things. And then the boards themselves are communicating with each other through the Ethernet cables here, right? At the bottom. And that's also where they're getting power to, or are they getting power through the debugger?
Yeah, so the power's coming in from over here. What you can't see off the side is this. At the end of this, there's a little USB-C socket, and I'm using they're called decoy plugs. Basically, it does just enough to negotiate USB power delivery.
Oh, okay.
So the USB-C plug over here has enough circuitry to basically ask for 20 volts at 3 amps. And that comes in over here, and so there's 8 wires on an Ethernet cable. 3 of them are ground, 3 of them are 20 volt, and 2 of them are this serial bus, like RS-485. So they're all daisy chaining power and data across here. You can kind of see here.
Is that a standard, or is that
no? This would cook. This would cook anything that you plugged into that was not this. They would
so
be
you
made
just picked
very
3
upset.
wires because you had 3 conductors, and you were like, just in case I want a lot of current or something.
Yeah, exactly. So the goal for this is to actually make like a bus for my house to do like LED lighting and sensors and stuff like that. So at 20 volts, 3 amps, I can turn that into about 12 amps at 5 volts. So if each like LED panel lantern is using between like 500 milliamps and an amp, that way I could put like 20 of these on, or 12 of these on the wall, and only have to inject power at one place.
Right.
But I also have these little jumpers here where you can choose whether you pass the power along to the other ports. So if I wanted to split it half and half and inject power on opposite sides, but have the data go all the way through, I can do that still.
Okay. Yeah, and you said IoT, but is there grand plans to actually get the internet on in here? Or are you going to keep this as an offline, in the privacy of your own home of things device?
Probably mostly on my own home. So I'll probably end up building like a server client that runs locally on my home network, and I'll probably put like a REST API behind it so I can make like interfaces and things like that. But I don't plan to necessarily have a cloud service working for it. And I have enough of a DIN DNS sort of setup where I can always get back to my home network remotely through SSH and stuff like that.
Right. And there's Bluetooth on these modules on the boards too? Is that...
There is. So these are NRF52s.
Okay.
The reason that I'm using them is because I just use Nordic parts for a lot of other stuff, and Nordic parts are just pleasant. Like working with them from a software perspective, it feels like someone designing the hardware had actually thought about software before.
Right.
So like
you can remap everything, right?
Yeah.
That's the main thing. You don't need to you're not constrained by hardware. Yeah.
Yeah, that's a huge thing where like if I accidentally wired some lines backwards, I just go, oh, okay, and I remap it in software. I don't have to respin my board or anything like that. So they have wireless. They're not doing anything wireless at this point. I might make like a wireless remote or something for them at some point, but right now I'm just kind of using them as regular old microcontrollers. And these little SOMs are not so expensive where like even ordering them from like AliExpress, the cost difference between this and a board like this which is still cheaper than I could make this from parts because they make them in China and sell them for super cheap, is like,
They're
this was
reusing
like
that
50
serial
cents
number.
more. Yeah, there you go. What you lose in serial number, you make up for in price. But yeah, so like I just use them because I'm familiar with them. And I mean, I've got a little cheap 20 volt to 5 volt voltage regulator here. And then these are the little transceivers for the serial bus down here that are doing the conversion. So like you just use a regular serial port to talk from the microcontroller to here. But these ones are designed to be on a bus. So you can have multiple devices sending and receiving, not at the same time, but they can all be listening at the same time. And as long as only one of them is sending, then you're good.
Right. And what I was curious, I don't mean to derail your prezzo if you had more you wanted to chat about, but I'm curious for the bus or doing all this. Why did you choose Ethernet? Is that just because the cable's cheap, as opposed to, I don't know if you could string together USB-C and keep it like very, hip or something, or if there are like distance limitations with that.
Yeah. So it's mostly so I've done a lot of like low volume prototyping before, and the trick is to use parts that you can source anywhere. And like the nice thing about Ethernet cables is I can buy a 100-meter reel of Ethernet cable, and that's just basically 8 parallel wires with a cheap connector on either side. Where like a lot of the more industrial connectors and stuff like that, they just cost a ton. Like connectors and stuff cost a ridiculous amount, but because Ethernet cables or like RJ45 jacks are used in everything, I use them for like anything that requires more than 2 or 3 wires. I probably will just put an RJ45 on there because I can run them at any length.
Mm-hmm.
Would not be a good idea if I was selling this as a product. That would be very prone to damage literally anything you plug these cables into. But for like, it's mine and I'll just put some red shrink wrap on the cable that says don't plug this into anything, I can get away with that on myself.
I mean, I've heard, this is a little outside my area of expertise, but I have heard people lamenting, I mean, because Ethernet is so fast now that like, I think they're kind of annoyed that like HDMI exists, for example, because I think the newer Ethernet has enough bandwidth to run monitors. And like, as an end consumer, I sort of feel that because I'm always like buying HDMI cables and they're not quite long enough, right? But then it's like, oh, but you can get these Ethernet cables for like $2, and at least they're rated to like very high bandwidth. I don't know if that works in practice, but it's sort of a interesting historical accident that like we have these different things.
I have an HDMI repeater actually. That's 2 boxes that each takes 2 Ethernet cables, Cat6 Ethernet cables, to let you stretch an HDMI signal like 150 feet or something like that. Yeah.
Okay, yeah. So
yeah, HDMI is impressive. It's like 26. I can't remember if it's 26 I think it's 26 connectors and 13 twisted pairs, and it's just ridiculous low voltage signaling, like differential signaling and things like that, where it is like it's like a really chunky Ethernet cable, but instead of like 4 pairs, it's like 13 pairs. So like the total throughput on an HDMI cable is pretty ridiculous, because you can do like 13 channel audio plus 4K plus 4K video plus everything like that. So yeah. I have no idea, but yeah, it's beyond me to be able to terminate an HDMI cable. But an Ethernet cable, I have a little crimper thing that costs nothing because they haven't changed in 20 years or whatever. But yeah, and a lot of this stuff, I just end up using whatever you can get at ridiculous volumes, or I just like in my parts drawer, I have just like for projects, I just have like a KiCad footprint that I use, and I just have a bag of single Ethernet connectors that are like the cheapest unshielded all plastic Ethernet connectors you can get, and I just treat them like 8 wires, you know what I mean?
Right. But I mean, power over Ethernet is a standard, right? I mean, you can power things over it. Like, did you look into that before rolling your own for this project?
I did. So I've actually, we're joined by Lachlan, so I'm going to throw Lachlan on the stream. Hey, Lachlan, do you want to give yourself a quick intro?
Yeah, sure. Sorry I couldn't join earlier, guys. So my name's Lachlan. I'm a university student, kind of in bunch of different kinds of engineering science. I've done a lot of Rust embedded, particularly recently, a lot of Rust embedded, and I do a lot of stuff with like rocketry avionics and stuff in the last few weeks, because I'm leading the electronics part of the avionics part of a university rocketry club where they're building a bipropellant liquid rocket engine.
Oh, wow.
Actually, it's really fun. It's really cool. Actually, I dropped in kind of at a perfect place because I also have stuff related to using Ethernet cables for things where they're not intended to be used for that.
Because you can spool them for the rocket. Like you can get a couple thousand meters of Ethernet.
It's a kite tail hanging out the back.
Yeah, we were thinking of using just Wi-Fi to talk to it, but we could just use a really long Ethernet cable.
How do you get the telemetry? Umbilical. Really long umbilical.
Fly by wire. But yeah, power over. So a lot of this is also because I'm going to be making 20 for my own home. Cost is a thing, and PoE is definitely something that's not super prohibitively expensive, but you need some additional parts and complexity because it actually you basically need inductors to take it off like you need a transformer on either side because it does things that are good for long cabling and good for those kind of things, but in terms of like size and heat and cost, the only thing that I need to turn 20 volt DC into 5 volts is this little thing right here, and that costs 80 cents. So literally the reason I chose 20 volt is because over a longer cable run, like let's say 100 meters or less, 5 volts would probably drop off, but the drop is basically linear to the amount of current you're pulling and the length of the wire, because it's how much resistance you have. So if you're starting at 20 and you've got 5 volts of voltage drop, you're still at 15, and these will work all the way down to about 6. It's less efficient because you are basically burning heat to the wire. But the nice thing about this is I can re-inject this whenever the cable length gets too long or I need to like reduce my amount of current. And you can buy these off the shelf for like, I can buy a panel of 10 of them for like $5 or something like that.
Like LDOs?
They're DC-DC buck regulators.
Oh, okay. So they're switching. Okay.
Yeah, so they're switching. So they'll be a little bit noisy, but they're more efficient. Like an LDO would be bad from the 20 to the 5 because you're basically burning 15 volts.
That would not be good.
Yeah, I do have a little LDO for the 5 to the 3.3 because my 3.3 rail is not being used for much, but the idea and the reason why I have these big connectors up here is to power like a bunch of LED panels and stuff like that, which run directly off 5 volts. So I'll pull my own face up here for a second. So like these are just like little smart LED panels and they take 5 volts. And I think this panel will do about 2 amps worth of power. So if I have, like, I don't need super clean power coming out of this, just enough that it doesn't glitch out the LEDs or anything like that. But each of these boards is going to be pulling like an amp. And actually those DC-DC regulators get less glitchy when you have a good amount of load on them. So basically I do that, and then I run all of my microcontroller stuff, and the actual RS-485 transceivers are running off the 3.3 rail. So they have a pretty clean LDO voltage rail, where like the big bulky 5 volt power rail locally is whatever. And the reason that I'm using USB-C rather than just like a DC switching supply is like I have these DC switching supplies, but they're chunky and I'd have to make a house for them and stuff like that. And I have to like terminate my own, mains power and stuff like this on this. But you can get USB-C charging bricks that'll do 65 watts at like no problem, like 20 volt, 3 amp, and they cost like 15 euros on Amazon nowadays. And it just makes, it's bending the right corner.
And can those do the USB-C? You can ask it for different, voltage, current, like combinations, right?
Yeah, and that's what this little cable over here is doing. I'm trying to see if I have them handy, but you can get they're usually called like decoy plugs, where it's just enough circuitry to ask for a certain voltage, where this one has like a couple solder bridges, and I have it configured to just ask for 20 volts, 3 amps, and it's just like a little probably 8051 or whatever that talks enough USB PD to be like, give me all the power.
How does that end up being cheaper than I mean just like to the manufacturer than the DC power supply that you just like held up?
The DC power supply is a little cheaper in terms of like if I was just buying a USB wall supply versus that box, like that's probably 10 or 15 bucks, where you can get like the GAN power USB PD ones for like 15, 20, 25 euros.
Yeah.
But I don't have to build a box. So
Oh,
some
fair
of it's
enough.
just like, okay, yeah, like if I was doing this manufacturing wise, I probably wouldn't use that. But for me, who's going to be making, like, I'll probably need 2 of these supplies if I don't have to sit down and build a box for it and terminate my old cables and whatever like that.
Totally.
Then it's just like rounding the edges that are painful to me when making a relatively low volume of them.
That makes a lot of sense.
Yeah. Um, let's see. Yeah, they were blinking, they work, and then what I was getting done this weekend was, uh, like I said, I originally just had, them talking over serial, but what I have going now is, oh, it's terrible on my screen. It's probably terrible for your screen. Let me find VLC, and I'll open the actual video. Downloads. Come on.
So what is the Ethernet rocketry that you're up to?
Oh yeah. So the part we're doing with Ethernet actually, well, so right now they've designed the rocket engine, and the aim is to test fire it this spring, and then we're gonna actually launch it like next year sometime. So basically what I'm working on right now with a few other people, but it's honestly mostly me, designing all the electronics for the test stand. So it's the way we have it, way I'm thinking of doing it right now is we have like a Raspberry Pi with like a custom hat on it that is going to have like a CAN bus controller and like a CAN transceiver on it, which will then talk to 2 other boards. And one of them and they have like STM32F4s on them. And one of them like has a bunch of MOSFETs and stuff on it. And that like controls various like pneumatic solenoids that like fire pneumatic valves and stuff to actually like start the engine. And there's a MOSFET to actually ignite the engine. And it's kind of interesting the way that works, because you can't just use a spark plug very easily. You kind of have to have a mini rocket engine to ignite the larger rocket engine. So we're using like an ST's rocket engine that we have like an ST's igniter for that, like
Right.
the model.
These are the little solid fuel tubes that I used as a child.
Exactly. It's exactly that. Like
Okay.
right off their website. And we use that, we fire that, and then we open up the valves in the right sequencing, which dumps the fuel through like the aerosolizer, and it all ignites. And a fuel and oxidizer. It's ethanol is the fuel, and it's nitrous oxide is the oxidizer.
Wow, it sounds like a party.
Yeah, it's cool. It's fun. The Ethernet part was the reason I picked a Raspberry Pi is kind of the control system that controls the 2 other boards. The other board has like a bunch of ADCs on it to get data from like thermocouples and pressure transducers and stuff. The reason I picked a Raspberry Pi is because I didn't want to mess with having to like use an Ethernet driver on like an embedded system. And so I can just connect through Ethernet the Raspberry Pi to like a ground computer and just run like a WebSocket connection over that to talk to like a website which has like displays various telemetry and stuff.
Right. Yeah.
But I'm thinking of having all of the sensors run over Ethernet, quote unquote. You can't see the quotes, quote unquote, Ethernet cables, because you can buy Ethernet cables with like twisted pairs that are shielded. Like Cat 7, I think, has like individually shielded twisted pairs, which would be great for all these sensors because they're like output millivolts and they're all differential pairs, like differential reading them. So it's kind of
Are these
ideal
are
to have
things
them
like
shielded.
around the test stand, or these are in the rocket?
These are gonna be in the rocket, like
Okay.
connected to the rocket engine. Like
Yeah.
we have
And
thermocouples.
so there's like
in the
pneumatic
chamber.
stuff? Is that
There's
for
also-
the pumps?
for the
Or-
valves? Actually, it's pressure fed, so it's not. It doesn't have any like turbo pumps or anything because pressure fed is a lot simpler, and we're like broke college students.
Okay. I don't know anything about rocketry. So like when you
Oh,
so
yeah.
there's no pumps, but like you say it's pressure fed, like is there a compressor like off to the side?
So
that's,
actually,
like,
we
charging
have
this, or-
pre-pressure. We have like tanks, and we like pressurize them, I guess, with a compressor, like beforehand.
Right.
And we just open valves, and all the fuel and oxidizer just kind of flow out. And we have like a kind of we have like regulators of some sort that'll take the pressure that flow from the tanks and kind of regulate it down to a lower but constant pressure.
Right. These are tanks of
Volumetric flow.
ethanol or nitrous oxide.
Yeah, and so they're not cryogenic and they're not like super pressurized. So I'm not sure what pressures we're running at them on, but it's like it's honestly not crazy.
Right. It's like a 2-liter bottle of ethanol.
A little bit bigger than that, but yeah, pretty much
Okay.
essentially that. And so there's like a bunch of valves that you have to open in the right sequence for it to actually like fire for the rocket to like turn on.
Make sure it's pointed in the right direction, and then actually
Right.
doing stuff.
Well, the test stand on the rocket's pointed sideways, so
Nice. Yeah, that's super cool.
it's a lot of fun
But
to
then,
work on.
yeah, I guess holding an actual tether for the rocket is probably not going to be a thing because, like, I guess you're tethered. Do you have something that'll like knock the tether off when it's actually launching, or
we
something that
haven't
disengages?
thought that far
Fair.
yet because we're just building the test stand. We're not actually building like the actual shell of the aeroshell or anything yet.
Gotcha.
That's like next fall, I think, is when we're going to be dealing with
And
that.
these little pumps and regulators and stuff, like these are little mechanical things that it's just off the shelf you can buy, and they
Yeah.
run off 12 volts or something to like
Yeah.
open and close valves.
Yeah, so it's pneumatically powered. So we're gonna have like basically like a pressurized container of air essentially, and then we have solenoids so that valves are pneumatically powered, and we have solenoids that open the pneumatic valves to open the liquid valves. But yeah, all the solenoids are like 12 volts, so we have like a 12-volt LiPo on it, and they use kind of remarkably little power. So that kind of surprised me.
Mhm. And are you designing all this stuff? Like,
Yeah.
is there a mechanical engineering team working on
There's
this, or is this
there's a
off the shelf?
mechanical engineering team that's designing the engine and the fluid mechanics part of it and all that kind of stuff. I'm
Yeah.
mostly just dealing with the electronics and the embedded software.
I was say
Okay.
you own everything up to the screw terminals where they actually put the like the solenoids and things like that on it.
Basically, and me and a few other people under me, and there also are there's also like a larger avionics team, but they're mostly focusing on like the ground station part of it, so like the website and displaying the data.
Very cool.
And you guys stream all this on YouTube, right? I can watch this next week.
No, but we should.
Yeah, I was gonna
That's a
say
great
I
idea.
would watch that.
Sounds cool.
Well,
I don't
I'm
need
sure
to update my smart home thing anymore. I'm switching over to rocketry now.
And we like your blinky lights, James, but I mean,
Yeah. I mean, I'm going to show you a demo where they say ping and pong, but there's no liquid oxygen going on with that.
It's like
Hopefully.
this is like a long-term thing. So yeah, we'll stream stuff maybe like in the spring when things actually launch, but there's really nothing too visible that's actually interesting before then.
It's all block diagrams now.
Block diagrams, some code. I was just writing a driver.
That's middle
for-
management stuff right there.
Yeah, it is. It's terrible.
Hey, senior architect.
Like I was going from I've been doing like working at startups like for internships and stuff, and now that I'm suddenly like doing work like in a club that has like a lot of aerospace students, and like kind of the aerospace industry is a little more conservative, you might say. We're suddenly doing lots of block diagrams and like several levels of like preliminary design review and like huge amounts of documentation, and it's very different.
I was saying, like, I'm trying to figure out how to make code on a screen more interesting, because like I can show you this video and it has some code over on the side, and I'll have some consoles of like the first device sending some stuff, this one is receiving some stuff, and then the fancy thing that I wrote is now I have DMA drivers where basically it can respond really quickly. So this one will hear the initial message and then tack on another message here. So like I this is fun for me to watch, but I feel like I need to draw more. Like I'm trying to watch, I've been watching a couple like YouTube folks who build assemblies, like Stuff Made Here is really good, or like any of the Mark Rober stuff, and it's like the code is always like a punchline to that of like, I had to hack on this and there were a lot of bugs for a long time, but like they spend the most time drawing block diagrams or showing how stuff is supposed to work, where I'm like, I don't know if this means anything to anyone, where I've got 3 consoles showing that I'm connected to 3 devices, and look, you can see that the output changes when I start and stop one of these console devices, which is huge to me because it shows my DMA stuff works, but like in terms of actual consumable content, I don't know if it's actually that interesting.
Yeah, code demos are really hard because I think you need to spend a lot of time telling people what they're about to see so that they can kind of conceptualize it. Because when you just show stuff scrolling down the screen, it's just like, oh, it looks like the Matrix. I don't know what's going on, you know? But like, so like even here, I like we saw this is the hardware that you showed earlier,
Yeah.
right? And so you had three of these little boards, and they were all hooked up to debuggers. So like, are these three terminals on the left like you're flashing those three different boards, and then you're like logging stuff out?
Yeah, exactly. So this one's the one on the far left, this is the middle one, and this is the one on the far right. So this one's sending some stuff, this one's receiving, and this one's doing a little bit of both. It actually, like, it's testing the driver where it can turn around and respond to a message immediately. So, like, when I stop sending, you see everything stops on the bus. When I start this one again, they're saying, like, ping and pong, and you see this pow at the end of it. But that pow that's at the end of it is actually this one quickly responding to that message, and the third one just hears that as one solid message because it's so quick that the message doesn't time out. So this is showing the ability to send, receive, and then also receive and quick turnaround to do a send, because my entire network stack that is built on top of this that I've built in a simulator essentially has two primitive, which is receive packet and send packet. So this is my low-level driver now being capable enough to send and receive packets over the physical interface. So I'm just shy of actually plugging this low-level driver into the network stack that I've been building on my desktop in a simulator for the last couple weeks and talking about in previous ones, where I've already built things like address discovery and all of that kind of stuff, where it all worked, but it was all mocked up in a simulator where I had a little like standard library channels and threads and stuff like that were pretending to be devices on an RS-485 bus. And the simulator was smart enough that if multiple devices tried to send at the same time, it would just corrupt all the bytes that were being sent while two devices were sending. And now this is where like rubber hits the road, where I was waiting for this hardware to be built. Well, for me to build the hardware. And now that I've built the hardware, I can actually test the driver on the device. It works, so now I get to plug the whole thing in and see if my four devices will auto-negotiate addresses with each other, and then also start sending and receiving packets. Because once I have that, I can start doing things like actually turning lights on and off, and then probably my next step is writing a bootloader so that I don't have to have every device on this test stand with a debugger attached to it. So if I do have 3 deployed devices in my house, I can just push code to all of them
things
whenever
over the network.
Exactly.
Yeah.
Exactly. Yeah. At least at home, it's always nice when you have the backup of walking over with a JTAG debugger and flashing it. I've definitely prepared and shipped like 200 devices to another country, done the installation, and a week later realized that something was broken. And I had over-the-air updates, but that was the thing that broke. So I got on a plane and I had to go manually reflash 200 devices that we had just gotten finished installing, which was...
I'm sure you learned your lesson, and that's never going to happen again.
Oh, that's
fine.
Trusting reliability of off-the-shelf parts. I guess what I learned from that is build everything from scratch yourself.
So I have a question. Well, yeah, I mean, to your very high-level question about, like, is this compelling? I think, it's a lot easier for me when you draw. And I think Stuff Made Here, the YouTuber, does a good job with this, right?
Yeah.
Because they sit down with their little iPad and, like, draw this conceptual overview and block diagram. So that always helps. And I find that, like, I used to do a lot of public speaking, and some advice that I heard when I was doing that, which I really like, is that no one's ever mad about being able to follow what's going on. Right? Like, it's much more common that you go watch a nerd give a talk about something, and then after 2 minutes, everyone in the audience is like, I have no idea what's going, and you just sit in confusion for half an hour. So I always try and err on, like, what would feel to me as, like, over-explaining, but, like, of course it feels that way to me because, like, I built this whole thing or whatever. That's why I'm at the front of the room explaining it. But, like, for everyone else, they're like, oh, this is great. Like, I can follow. So, like, especially maybe for streaming, too. I don't know how many people jump in, and haven't seen any of the past streams or seen the past 6 months or whatever work on this thing. And so it's easy to, like, or it can be nice to have a recap of, like, here's what we're making and, like, what's going on and stuff like that. Yeah, in terms of the demo you just gave, though, I have a question, because you said, I think, that there's, like, packets and stuff, right, going on in there. But then you also said, what if the first guy says ping, the second guy says pong, and the third guy says pow. But if the third guy says pow in a certain time window, the first guy thinks that's part of the second guy's message?
Yeah, so this one's sending. This one basically is tacking extra messages on. So this actually isn't using the real network stack with packets and stuff like this.
Okay.
This is just treating it like a regular serial port. So it's just bytes on the wire.
So you just time out. That's like like
Yeah.
if we haven't heard anything for a certain amount of time, then we're going to print. That's what.
Yeah.
Okay.
This one has a much tighter turnaround because it's all interrupt and DMA driven. This one has a timeout of 100 microseconds. So
Wait, are you
after
pointing at things? We don't see the things.
oh, right. It helps if I actually reshare that part of the screen. So this middle one, it has a timeout of 100 microseconds. So basically, if the line ever goes quiet for more than a couple bytes, it jumps in. Whereas this one on the bottom, because it was my original test code, it's much squishier. It will wait 100 milliseconds or something like that to timeout. So as long as this one jumps in between 100 microseconds and 100 milliseconds, which is a pretty huge time window for this, then I'll be good to go. And I would have had some scope traces. I ordered a Cele for a logic analyzer, and the one that I got was dead out of the box. So I was hoping to have some logic traces here, but maybe that'll be next week's update where I can actually see how close I hit it to exactly that 100 microsecond or 100 millisecond timeout and stuff like that.
Mm-hmm. And the connection is full duplex? Like there's
It
two
is,
wires?
but it's a shared medium. So it's 2 wires, but it's a differential signal, which is how it can be resistant to noise and it works over a longer range. So if it's bidirectional, but it's half duplex. So only one of them can be sending at any time. So you have to be polite after you're done sending and basically disconnect your transmitter and only have your receiver listening at that point. So it's a shared bus.
Okay. And do you have to write then the protocol for like if these guys are sensors or something and 2 of them get an event at the same time and they want to talk about it, like it's possible that they'll yell over each other by accident.
Yeah.
handle
And
that.
that's exactly what my higher level protocol does. I have kind of 2 roles. I have the DOM and the sub, and the DOM basically is the one that gives addresses to everyone on the bus, and its job is basically to call on everyone to talk. So it would, after it's assigned addresses, it would say 3. If I have a message for you, I would give you the message. Otherwise, I would just say, now you have this much time to send me a response. So it's basically calling on people, and if they don't say anything for a certain amount of time, it just goes, okay, you're done. Now 4, your turn.
Right.
So it's essentially round-robining all of the devices on the bus.
This USB works like that, right?
Yeah, very similar. Very similar, where you have the host driving the connection, and then you have the end devices with specific addresses that were given to them, where it can go through like that. But yeah, very similar to USB. Yeah. There's a lot of protocols that work.
I remember
similar to that.
feeling very betrayed when I learned that I guess you can set interrupt priority, and it just means the host will ask you more frequently if you have anything to say.
Yeah.
It's just like,
Yeah, that's the
feels
one-
a little cheated.
That's the one that's challenging because when you have like a regular desktop PC, you're beholden to not so tight timing requirements and things like that. Here, where I can say like, look, 100 microseconds. If you hold the line quiet, your turn's done. Like I can make those kind of guarantees on a microcontroller because I have that level of precision. But if you're firing from something like Linux, anything sub 1 millisecond is pretty hard to get consistently right unless you really like build your system to try for that kind of thing. So the plan here would be to have like a USB cable connected to one of these and have it act essentially like a modem for the rest of the network. Because these Nordic devices also have USB, so I can set up a USB to serial connection with much nicer timeouts and things like that over that connection and treat one of the devices like a modem for the rest of the bus.
Mm-hmm. Huh. I had a design question kind of about this stuff and sort of Rust embedded world. Because I've been very impressed and excited about a lot of the work that people have been doing with like probe run and what was it, probe.rs? Just like this whole toolkit. Because I had been using some of the Seger stuff because I used to do some Nordic things last year and learning about Segers like RTT and everything. And I was like, oh, this is clever that I can do my logging through the debug through these circular buffers or whatever. So it's cool to see that in Rust world, and I know probe run uses that. But I was curious. I was looking around for prior art and how people do communication from their computer to their embedded things, and so I got the sense that like, okay, I'm happily using probe run and like writing my log statements, and it's great. But if I want to talk to my microcontroller, I'm not sure exactly how to do that. Right, like aside from take all of the individual crates that probe run is built on top of and like writing my own logging communication system. And so I don't know if there's if people have figured out nice ways to do that, or if everyone kind of rolls their own, or like what other people are up to.
Yeah, so Probe Run, which is written by the folks at Ferris as part of Knurling, is built on top of the PowerBus libraries, which are basically the sort of like a library style replacement for OpenOCD, for folks who know what OpenOCD is, where it manages all the connections with the debuggers, which then talk to the end devices. So PowerBus and the RTT crate, which is built on PowerBus, both have the capability to do multiple channels in either direction, where essentially it's just ring buffers that are pointing in opposite directions. Probe Run, which gives you all this nice debugging and timestamping and like efficient messages and stuff like that, that right now is written to only open one RTT channel on the outgoing direction. But there's nothing preventing
outgoing is device to
Sorry,
computer.
yeah, from the target to your host.
Okay.
So in the logging direction. We've had some chat. I think the only reason that there isn't a way to go the other way is because no one sat down and done the design work of like, how would we have that interface? Is it like is it opening up a socket? Is it opening up a pipe from like standard input or something like that? Where the building blocks are there, but the like user interface design isn't. But if you use the underlying tools, like there's a much simpler RTT command line tool called, I think it's just called RTT host, where they have a command line that's built on top of the same libraries, but I think it gives you the ability to open up sockets in both directions. And the way that all of this logging stuff works is called deformat, is the protocol that we use there, basically over the wire for doing that compressed logs. We give deformat RTT as like out of the box experience. So Probe Run uses that out of the box, but we've also written those as standalone libraries. So basically any way that you can get that stream of logging data, it can do the decoding and timestamping and everything like that for you. Where I've been looking, what I probably end up doing for this project, because I don't want to have a debugger attached, but I still really like having these nice, efficient logs and stuff like that. On my network protocol, I'll probably have a specific socket that is just for deformat data, where maybe it'll send like the ID of the binary that's sending it, and the basically like what firmware is sending this message, and then what are the contents of the message, and then have a decoding server that basically sits on the other side of that and just has converged logs for all the devices. Because essentially, as long as you can make a stream of bytes, you can decode them on the other side, because all they really are is like compressed, basically. And deformat has this trait that you use for how you sync these bytes, and the deformat RTT crate is how most people use it, and that just syncs the bytes over this RTT protocol. But you could use a serial port, you could use Bluetooth, you could use RS-485 like I'm going to, and so like that's probably going to be the first thing I build after the bootloader, is the ability to have like some server that sits on the PC that says, okay, I got a message from this firmware, this is the contents, decode that out into, I don't know, a big log stash record or something like that, where it has like the device ID and the message that I got. So instead of having three separate windows like this, I can just have one rolling log something that shows me what all of my devices are saying all the time, that I can filter and do stuff with. That doesn't answer your question on how to go the other way, but I mean
the pieces are there, right?
Yeah.
Like, yeah, and I kind of agree. That was the sense that I got, that it's more of the UI problem, but it's, you know, I'm thinking about it kind of in public, because normally I would just, you know, and if I wanted to get this done, I'd probably just fork Probe Run and like add my the incoming channel, I guess would be the terminology, yeah. But then that doesn't help the other people who are going to be in the exact same situation, where they're like, hey, this Rust stack is really nice, you know, I want to use this, but then I want to talk to my thing. So, but yeah, I agree. Like making it pluggable is kind of tricky, right? Because I don't know if you'd have to. You don't want it to be compiled into Probe Run, right? You want people to be able to install that, but then now you have to talk over a socket or a pipe or something on the host side.
It's definitely possible. What I tend to do when I'm working with devices, let me pull one up this one's old, but I think it'll demonstrate it. Otter pill. So like if you have a device that does have USB, often I have my debugging line, but my primary communications I put over something like USB UART or something like that. So let me pull this up on the screen. So this is a...
Why is that? I guess just like if you can for your application, like why not do everything over the debug line? Because my understanding with like RTT and stuff, it seems to be very fast and efficient.
It's fairly fast and efficient. I guess the question is, how is this communication going to be used outside of prototyping? Because a lot of the times I have my debugger attached when I'm doing development, but then when I actually want to put the thing up on a shelf and still talk to it, I'm probably not going to leave it with a debugger attached all the time, because then I actually need a PC that's talking to the debugger and things like that, versus
Right.
this is something that I've done where Vintage, you don't really have to worry about what it is. It's just like a little button panel. But it's an STM F0 something. And I've written this library called Postcard, which is a Serday implementation. So it's a binary protocol that works with Serday. And I basically just use Serday messages back and forth as sort of like an RPC. So what I end up doing for a lot of these is I end up having one crate that is just data types that are defined with derived serialize and stuff like that. So this uses the same if you were using like Serday JSON or whatever. You just say derive serialize, deserialize. So I end up having this library that has all the shared types that's going to be used on the embedded system and the desktop system. In the embedded system, I just decode them off the UART. So I turn like the UART into a stream of bytes in like a serial port mode, and then I can decode that on the actual embedded side. Kind of like I was showing here, where it basically just finds a whole message and then it tries to deserialize it. And if it was able to deserialize it, then it puts it in like a message queue or something like that. And I more or less do the exact same thing on the PC side, and I'll make like a Vintage CLI where I'll make like a command line program that basically does the same thing. It just opens up a serial port, like a USB serial port on your PC side. And then essentially after you get one layer up from just having a bidirectional serial port, it ends up acting almost exactly like Rust channels, where you just are like, if you forget that serialization and deserialization is happening under the hood, you just are sending a struct in from one side and receiving a struct out the other side, and you can turn around and send a struct back the other direction and receive that out the other side. So almost all of and this is actually what I'm doing over the 485 bus as well. My whole network protocol is serialized and deserialized like this, where I have, this
Are you
ICD.
using Postcard for that?
Yeah, Postcard is something I use because I wrote it. So
Yeah.
I use it
used
for
Postcard,
like everything.
2 years ago or a year and a half ago. It was
Okay.
a great experience. Yeah. Because I, just had to, it gave me packets basically, right?
Yeah,
That's
and
the thing.
That's the big thing you need most of the time is framing. So it uses COBS for framing, where you can turn a serial byte stream into an iterator of packets, basically, because it handles here's where this message starts and here's where this message ends, basically, in a pretty efficient way. So yeah, I use it for almost all of my serial communication, where there isn't like, if you use a packet radio where like the radio itself is saying, this packet is 8 bytes large, then you don't need something like that, because you're already getting like chunks at a time. But over a serial port where you have no idea where one message starts and the other ends, something like COBS for framing works really, really well.
Right. And when you're serializing Rust structs, I can't recall, I guess you need to make sure that both the client and the server or whatever, both sides are on the same, like you can't change the format over time or anything, because like each struct is getting like a type tag and it's getting a magic number or something like that, and that might change.
That depends on the serializer.
Yeah, Postcard, I will say, doesn't deal with that. Postcard just assumes that you have it right on both sides.
Okay.
But you could definitely build something that had... The reason I haven't tackled this is because there's like 10 different ways or there's a lot of different thoughts here of like, how much do you try to do recovery when the semantics behind that message may have also changed and things like that. So,
and if you intend your system to be open or closed, at the end of the day, because if it's like, you're running the same version on your firmware through over-the-air updates in your house, like, doesn't really matter. You don't want the overhead of, self-describing messages or something.
But I know other folks in the Rust ecosystem who actually use Postcard in production applications, and they've written essentially a CI test that basically has every version of their interface, and it makes sure all the ones that are reported in a certain way are always correctly encoded and decoded to each other. So they just kind of brute force it in CI to make sure that if they ever change their message definition library, that it's always backwards compatible at that point. And I think they do some kind of version reporting for that as well. But this is just one building block, and then what your strategy is on top of that really varies by what you're trying to do. And like you said, for me, for my home, I can just push a firmware update and have everyone talk the newest library. But yeah, it definitely depends on your use case and how updatable devices are and things like that, where that person who's using it in production, I think not all of their devices get updated all the time, but they can still at least guarantee backwards compatibility and things like that.
Mm-hmm. For applications that are always going to be used with a PC, or like with the Rocket test stand, for example, like I'm curious why not use the single wire debug or something? Like, do you think you hit a bandwidth limitation and that at some point you want to use USB or something like that? But I wonder if, there's a big reason where it's like, oh, it's not designed for this, or if it's like, no, this is totally fine actually to use that protocol.
Like I said, most of the time for me, it's just I want to go do something else with it. Like that device that I was talking about was intended to be plugged in over USB to my PC. Mm-hmm. So I wanted like the client that it was talking to talk over USB, because that's how I plug it in. Or like this one, which has RS-45, because there's going to be a bus. That's how I want it to talk. If I was just building like a single use thing, like I needed to like move some motors around for a proof of concept, I probably would entirely use RTT and maybe a button or two to like go or something like that. There's no limitation to it.
That's a good question for the rocketry stuff as well. I mean, we totally could use just like a, single wire debugger and have the multi, kind of a full duplex connection. But I think there's kind of a couple reasons we don't. One is it's like weirder. It's like it kind of might go over the weirdness budget for the people who are just kind of coming into this.
I mean, you're compressing tanks in nitrous oxide, man. Like you're already at the deep end.
I mean, that's for the mechanics, yes, but for the software part, I think a lot of the software people on the team are like doing like React stuff and like web dev and stuff like that. And so I think just introducing them to the concept of like debugging an embedded system is something new. And then saying, oh, we're going to use the debugger to talk to the test bench, like I think it kind of goes over the weirdest budget. Is also,
I was going to say, that being said, like the whole reason we have probe run is to make embedded stuff feel like server dev, like where,
true.
You hit run and you get a scrolling list of log, which has actually been really nice for us for teaching non-traditionally embedded folks embedded stuff, because they go, oh, it's like I'm SSH'd into the machine and I'm just getting my logs back out. Like that totally makes sense. Like that's actually a mental model that makes way more sense for a lot of people than like if we were using something like GDB in a TUI window or something like that, I'd be totally with you on that. But like that is sort of the thing that we're trying to do with Probe Run, is to make it feel no different than running desktop programs. I
mean, even if you know all the background, like it's nice, if you go to the coffee shop to work on your thing, to have like a USB dev board and to not need like 17 other wires for like a USB UART converter, blah, blah, like
that's totally
up the whole table. Like I don't know. Yeah. It seems doable for those applications where you're going to have stuff plugged into a computer. And so that's sort of like, you need the debug to work anyway. And so it's sort of like, is that sufficient then for the rest of it too? Or like, why not?
Yeah. Their answer is like interfaces are just so easy in Rust. Like there's getting USB working on this took me like 5 minutes, because there just is a USB library that is portable to all the different devices. And like all I had to do to get a USB serial port was in the main. There's like some example code that I set up that configures the USB in a certain way. And like literally that was just copy and paste code. And then I just have to have like a little event loop that periodically says, is there more data? Grab it. If there's not, should I be sending data? And like, I guess the triviality of it means that I just use whatever makes sense, because on top of that, I'm still probably going to be using Postcard, because like when you're sending data over the wire or whatever, you need some kind of formatting. Like logs are nice because they're always the same. Like you're sending a message that gets timestamped with a log level, whatever. But like once you're communicating back and forth, you have an equivalent problem, which is like the RPC or message schema kind of problem, which is going to be the same whether it's over RTT, whether it's over USB, whether it's over that. And if they're all like 10 lines to set up, I guess I'll just probably use whatever I used in my last project. Like a lot of this comes out of I set up USB for that one project, and my next project will just copy and paste from that project, and then like I'll just use different message types or whatever. So there's no like technical limitation here.
That's
it's
true.
just whatever you're doing.
I don't know too much about the USB protocol itself. Doesn't it have like packets by like as part of the protocol? Do you need to add additional kind of framing in your protocol on top of that?
Could. So USB framing is also dependent on your host and device, where like so most of the time I end up using the USB serial protocol. Like I don't go all the way down to raw USB. I just use like CDC ACM.
Oh, okay.
So it handles like
then.
yeah, it handles like chunking and reframing and stuff like that. If you were doing something where you cared a lot more, you might end up doing your own like totally custom. I got a packet. This is expected to be a frame, but like some devices have a maximum frame size of 8 bytes, and some of them have 64 bytes, and so like you end up having to worry about a lot of implementation details when you move out of something like a dumb byte stream. And the dumb byte stream is pretty quick. Like it'll do like I know on the Nordic device you can do 60 or 70% of the theoretical maximum, and that's just because no one's bothered to squeeze that last 20 or 30% out of the USB driver, because it means you have to like super tightly double buffer everything in really tight timing, and no one's needed that yet.
Yeah. So does that driver, does it just, you just like give it some pins or something to read and write from?
There's different ones for each. So there's one overarching library, which is docs.rs US. It's like USB device or something like, or yeah, it's USB device is this. So this is kind of like the embedded HAL of USB, where this is basically the, it helps if I share my screen, you don't just see the glow on my screen. Where it's got some like common abstractions where you can do things like set up a USB CDC ACM port on top of this. But then each piece of hardware will implement.
So it'll use the USB support in the hardware then.
Yeah.
Okay.
So like the STM is nice because even though they have a bunch of different chips that all do USB in a different way, they really only actually have like 2 or 3 USB engines. So the same like driver code works for all, like a third of them all use this one, a third of them all use this one, and a third of them all use this one. But there's also been folks like Disasm wrote the implementation for the NRF52, which is merged up now. So basically you just have to say like, okay, turn my hardware into a USB bus implementation, then plug that into the USB device crate, and then your USB code will literally work the same on any piece of hardware that has USB support that you use it on, which is just not the experience outside of Rust, where everything is like totally different on every chip. But yeah, I mean,
that's really nice. Yeah, I feel like it's kind of getting towards in that general direction, stuff like Zephyr and stuff, but it's still very, very different experience. But that's great. That's really cool. Yeah, I'll look into using USB. Though one of the reasons, I don't know, what distance could you expect on a USB connection? Like what's the
physical
maximum
distance?
Yeah, physical distance.
like 10 meters would be pushing it probably.
Okay.
5
Right.
meters is probably closer to your actual max. Like
Okay,
you probably
we
can
need-
get extenders and stuff, but
We need something more like 30 to 100 meters. So that's why we're using the Ethernet.
That's the size of the kill zone.
Yeah, we want to be as far away as possible. I would not want to be anywhere close to that. I mean, it's students designing this stuff, man.
Where is this, by the way?
This is in State College, Pennsylvania, in the U.S.
Cool.
Yeah.
But yeah, like the RS-45 that I'm using, I think it will do, like it's rated up to 12 megabit. I think it will do that up to like 100 meters if you're nice with your cables. But if you take it down to like 115/200, like a way slower baud rate, it'll do like kilometers. Like this one might not because it's 3-volt signaling, so eventually your lines will drop off. But you can do higher voltage like 485 where you won't lose as much and things like that. Or you can get like repeaters and stuff that are we'll keep it going. But most of it comes down to like, at what point do you lose your 3.3 volts to resistance on the wire or whatever?
Right. That's interesting. Yeah. Yeah. I mean, doesn't need a lot of bandwidth here. So I guess there's lots of, but honestly, the reason I wanted to use Ethernet was we could just use Linux with like the preempt RT patch. So it's kind of, sort of kind of real time. And then we kind of like use that to control the other embedded boards.
One of the things that like I'm surprised that I don't see more people doing is like really focusing on buddy systems. Like I'm surprised things like the IMX7 SoC aren't more popular, where they have like a Cortex M and a Cortex A on there, because in embedded, networking sucks, and like allocation and logging and writing to a file sucks, and like doing anything real time on Linux sucks. But like having a Raspberry Pi with a shield with a microcontroller on it, and just like doing your Ethernet to that, and just having a little Rust program that just throws things over serial port to your microcontroller is like the best of both worlds in most cases, because you can like keep all of your motor control and sensor control and things like that in real time, and then just speak UART or SPI to the Raspberry Pi and just do postcard over that, and keep all your real-time stuff real-time and all of your non-real-time stuff not real-time. If you can partition your system, I guess it depends on like if you hit the button that says stop on your remote system over Ethernet, how much latency are you okay with before that message hits the...
Well, it starts at a React app is what I heard, and then went over WebSockets. So
so that's important. We have a big button that just kills, like it's connected directly to a relay that's between the LiPo and everything else. So we can just kill the whole system, and all the valves fall by default into the right positions that kill all the flow. So we don't latency between like the ground station and the test stand or the rocket when it's actually flying is not going to be a huge deal, especially because when we launch it, I mean, it's going to be wireless communication, probably not a lot of bandwidth, probably because most likely we'll be using something like XB or just maybe some homegrown, 900 megahertz radio protocol. So probably not going to expect a huge amount of bandwidth from that.
It'll just be another serial port, but it'll be a wireless serial port.
Essentially. I mean, I posted on Twitter a week ago or a couple days ago. I was like, well, could I use Wi-Fi to talk to something that's going straight up very fast to like 10,000 feet? And people were like, no, that's a very bad idea.
I mean, they do it with the drones, but like they have the super directional antennas that they use for like
slower.
the DJIs. Yeah,
that's true.
I wonder how far you could get Bluetooth Classic.
Oh, God.
This is actually, I mean, my only wireless. This is actually when I use Postcard, because I was making a little robot, and you could buy these $2 Bluetooth Classic Bluetooth to serial port, and I was like, cool, I'll put one on the robot and one over here on the computer, or the thing that's hooked up to the computer, and then you can drive the robot through the computer, and it was like, worked great, in my office or whatever.
I mean, like on the NRF52s, there's, Nordic has this proprietary protocol called ESB, which is basically like, how can I turn my very nice Bluetooth radio into the dumbest packet radio that could ever exist? But you can get like up to 2 megabit per second on that, or you can like turn the coding all the way up and get like super long range on that. I think they have numbers like quoted like 2 kilometers with a nice antenna and things like that. Definitely not at 2 megabit. It's much more like 10 kilobit or something like that. But there's also
a little more than that.
Yeah. There's a Rust implementation for that. And then the other thing that you might find interesting is Nordic just started selling a power amplifier low noise, or a PA-LNA for their devices. So you can push the signal strength all the way up to the legal limit for 2.4. So like I've been meaning to get one of those and do ESB with the ESB crate over that distance, especially with like a directional antenna. Like if you had like a CAN antenna or something like that you could reasonably track your rocket with, you'd probably get some pretty ridiculous range out of that, and still probably in the hundreds of kilobit per second sort of range.
Yeah. The tracking is a little bit difficult, kind of a chicken and an egg problem. Presumably we have a GPS antenna on the rocket, or maybe multiple, and it's transmitting its like height X, Y, Z to the ground station, which would then pivot which would do some kind of do some trigonometry and pivot the antenna to point at it. And so kind of like all the way up. Honestly, probably wouldn't even bother with that. I just put the antenna right next to the rocket, pointed straight up.
Make it less directional. Take a little bit of a gain hit to
Right.
make your life way easier
And
in
just-
the aiming direction.
And just put it right next to the rocket, so it's always going to be in the kind of the direction in the.
We were joking about Ethernet, but like presumably people do use a wire, right? Isn't it how like torpedoes and stuff have a little wire going back to the submarine and shit? Like,
I don't think they've done that for a long time. Maybe they do. I mean,
Yeah.
I guess maybe they have like a spool of really thin
Yeah.
like copper wire or
like
something.
mag
that.
wire, basically.
Yeah.
You probably
Pretty
could, but
much.
it would get heavy and it would knock the rocket. I don't know how much thrust you're playing with, though.
yeah.
I
I also
think-
don't know in terms of, or sorry, the problem space, right? Like maybe you'd want the super high bandwidth in the first 10 seconds because that's usually when they blow up.
Well, yeah, that's I don't know. I don't think we need super. I mean, it's just outputting like telemetry, like basically ints to the ground, like like maybe like 100 kilobits a second or something, like not very much. But I mean, all of it's going to get logged on the device itself to like an SD card, or even better, like I guess an SD card would probably have enough bandwidth, or maybe multiple SD cards, and hope that one survives if it blows up. Though who knows? Maybe we'll add a black box of some sort. That would
Nice.
be fun.
Well, I do have to call it here because
Okay.
I've got to go eat dinner. So it was excellent to have all of you on, and thanks for being here to listen to my ideas and poke me in to explaining certain things. But yeah, thanks everyone who's watching now or later. And yeah, if y'all are interested, I'll probably do this again next week. So if you're not doing anything on Friday, that's usually when I'm doing my update. So thanks everyone for joining, and I'm gonna go
James.
ahead and call it here.
Thanks, y'all.
Yeah, see ya.
See ya.